and lignite, these other kind of carbons were used. And this is the installed capacity, and this is actually what is produced. So these ones are their maximum levels because we could not use more than 40% of each. And we see that gas is basically installed as a backup to have it there when we need to use it. When we include environmental objectives, then the aeolic, the wind energy comes into the mix, and the hydraulic as much as we can. We cannot install more than that, and we use it up, and gas is also a backup. And when we want to improve vulnerability, as I said the other day, then we have the solar energy as well. A little bit of nuclear that was there to complete the mix, which the decision makers didn't like very much because they were from the environmental department, but that's what came out, okay? So that's the first application. The second one that was hired by Endesa, which is one of the main electricity companies in Spain, was to find the optimal dimension of a solar thermal plant. That is something like this. Basically, it's formed by three elements. We have the solar field, which are the panels. At the solar field, what we do is to heat up some fluid, water or oil, and then we produce steam, which is what will later on produce the electricity at the generator. But this steam, if we produce more than we need, we can store it. And we have big tanks there, or we can use tanks to store this remaining steam. And still, we can also use an auxiliary boiler that uses traditional fuels. In this case, it was an oil boiler, so that